Okay, we will be working through lesson 2 on page 261. This is going to just continue off with what we learned yesterday. And to review what we learned yesterday is what we are doing is we are solving systems. So just at the top of your page, write solving systems. A system, remember, is just an equation, and because it's systems, we are looking at two equations at the same time. So what we are doing is we were given two different equations, and we were graphing the two different equations. So on your Cartesian plane, we would have graphed the first equation, and then we graphed the second equation. And solving means we're looking for a solution. So what was always the solution to these two systems yesterday? Ainsley? Where they intersect. So the solution to two systems is where the two lines intersect. So that would be right here. So let's just write the solution is the intersection of those two lines. So this would be the solution. So what we would have done is we would have said, okay, what is that x coordinate? So let's just say that was at 3. And what is the y coordinate? Let's say that guy's at 2. The solution to the two systems would be x comma y, which would be 3 comma 2. Or it would have we would have written the solutions as x is equal to 3 and y is equal to 2. That's how we would have written the solutions. What we're going to be exploring now is there are actually 3 different types of solutions we could have. So what I want you to do is we're going to be exploring this. It's the number of solutions. So yesterday's work, we all had only one solution, but there's actually 3 different scenarios. So I want you to flip your page, and at the top of this page, so 322, I'm going to show you the 3 different scenarios. So when we're looking at the number of solutions to a system, there's 3 different cases or scenarios to consider. So the first case is what we did yesterday when there's one solution. And that looked like this, right? And that would be the solution. The second case is you could actually graph 2 lines and have no solutions. Does anybody know how that would be possible? How could you graph 2 lines? They have to intersect to have a solution. So how could you have 2 lines on a grid that would never intersect, which would leave you with 0 solutions? Basically, they're both parallel, right? If you graph 2 parallel lines, so just jot that down, this example. If you have 2 lines that are completely parallel, these 2 lines will never intersect. Therefore, you would have 0 solutions or no solutions. So case 1 is one solution. Lesson number 1, that was all one solution. Case 2 is no solutions. The lines are going to be parallel. And the third case is actually going to be infinite number of solutions. So think about what that would be. How could you graph a line and then you graph the second line and they have infinite number of solutions? Any guess what that would be? What are you thinking? Yep, more than one point, they're touching at infinite points. What would the 2 lines have to be for them to touch at infinite points? The same. Yep. If you have 2 equations and they're both the same, what would happen is you graph the first equation and it would look like this. If the second equation is identical, it's just going to go right over top of it. And it would look like that. That would have infinite number of solutions. So let's look at these 3 examples. The nice thing about these 3 examples at least these first two, is they're all in the form of y is equal to mx plus b. Because remember, in order to do this, we need to always be in that form, slope y-intercept form. So let's label these two systems. We're going to do this example on our calculator, but then every other example, we actually don't even need our calculator once you understand the three cases. So system number one, I'm going to put in blue. This is in y is equal to mx plus b. What is the y-intercept of this system? It is 5. Yep, the y-intercept of this system is 5. So 1, 2, 3, 4, 5. So that's going to be the y-intercept of system 1. And this system, does it have a positive or a negative slope? Positive, yep, because the slope is 1, or the slope is 1 over 1. And remember, a positive slope, it would look like this. So I'm just going to sketch this even without graphing it. I'm just going to do this, and then we'll graph it after to compare. System number 2, Juan, what is the y-intercept of system number 2? 1. So the y-intercept is 1. And Tristan, is system number 2 a positive or a negative slope? Careful. It's the number in front of your x for this guy. It would be a negative slope. So remember, negative slope, that's the graph of a negative slope. So this one is going to look something like this. How many solutions can I expect from this? One solution. So this is what we remember we did in lesson number 1 yesterday. So let's actually review this so that we could find out what that one solution is on our calculator. And then, Michaela, I'll show you what I showed yesterday that might not have been in the video. Okay, take your calculators out and go to y is equal to. Clear anything that you already have in there. And let's put that first system in, which is x plus 5. Then let's put the second system in y2, and that's going to be negative x plus 1. When you graph it, there would be your graph. We know that the solution to this system is where these two lines intersect. So how we found that was second function trace. We hit number 5 because we're looking for an intersect. And you bring your cursor close to the intersection. It could be right over top of it as long as it's close to it. You hit enter 3 times. The reason why it's 3 times is because your calculator is going to select this line, then it jumps to this line, and then the third enter, it's going to jump to the solution. So you hit enter 3 times slowly. So 1, 2, 3. The solution to this system is negative 2, comma 3. So let's write that down. This has one solution, and the solution is at negative 2, comma 3. To review what I showed yesterday, let's say that this was a decimal. What we did yesterday, quit out of here to get to your main screen. So just hit second function quit. If, let's say, it was a decimal and you wanted to convert that to a fraction, what we did is if you hit the X button and then enter, it will actually give you what that X coordinate was, which is negative 2. So if this was a fraction, if this was a decimal, the decimal would have gone here, and then you could have math 1 fractioned it. The y, we could do the same. What number was y? It was alpha what? Alpha 1. So if you hit alpha 1, here's the green y, hit enter, and the y coordinate will come out. Again, if that was a decimal, you could just hit math 1 fraction and it would turn into a fraction. Okay, let's look at system number 2. What do you notice without even graphing this? Anybody notice something about these two systems? They have the exact same slope. Both slopes are what? Positive or negative? Both slopes are positive. This is what a positive slope looks like. Okay, let's put this first one on. So it's got a y-intercept of negative 8. So I'm just going to write negative 8 here. And I know it's a positive slope, so I'll put that. The second system has a y-intercept of 6. So I'm just going to say that that's 6. And it has the exact same slope. So it doesn't quite look like this, but they're parallel lines. Let's put this into y1 in our calculator, this into y2, and you'll see how they are the exact same, they're just parallel lines of each other. So let's go to y1, and we would type in 2x minus 8. Let's go to y2, and we would type in 2x plus 6. Graph that. There was system 1 in blue. Here's system 2 in red. They are completely parallel because their slopes are the same. These two lines would never intersect. Because they're parallel lines, when it says the number of solutions, because the question is state the number of solutions, this would have no solutions. Okay, the last scenario would be C. So system number 1, we could quickly sketch because it's in the form of y is equal to mx plus b. I know that my y-intercept is -2. My slope would be 3 over 1, rise 3, 1, run 1, but it's just a rough sketch. It's a positive slope, so I know that's the direction of a positive slope. So I'll just have this. System number 2, we have to do a bit of work for because this is not in the form of y is equal to mx plus b. So I want you to see if you could get that in the form of y is equal to mx plus b. I just have it written on this page. You're going to box in that -2y and decide if it stays or goes. Angel, do you want that -2y to remain or do you want to move it? You would move it. You always want your y to be positive. So add 2y to both sides. Then you would have 6x minus 4 is equal to 2y. Evan, what do you want me to do from here? Reduce. How do I do that? Get rid of that 2. I'm going to just rewrite this. This is system 2, so I'm going to write y first. Y is equal to 6 divided by 2 is going to give you 3x minus 4 divided by 2 is 2. So over here, I'm just going to write that equation, 3x minus 2. Y is equal to 3x minus 2. What do you notice about equation 1, 3x minus 2, and equation 2, 3x minus 2? They're the same. Let's graph this. If you have a color calculator, it shows really nicely. If you don't have a color calculator, just watch up here and you'll be able to see it better. So I'm going to put 3x minus 2 in both y1 and y2 because they're identical equations. So 3x minus 2 and 3x minus 2. What your calculator will do is the following. It always graphs y1 first, and it's going to graph it with a blue line. Then really quickly after, it will graph y2 with a red line. So it's going to happen quick, but watch what happens when I hit graph. There's y1, there's y2. One right on top of the other. They're touching at infinite locations. So for the sketch, I've got my y1 in, y2, I'm just going to put right above it. And the number of solutions, there are infinite solutions. Let's fill in this chart. So we're going to start on this last column, infinitely many solutions. So what we just did, the case we just did, infinitely many solutions, they have to touch, right? They touch completely. One line goes over top of the second line. So if we have infinitely many solutions, what it's going to look like is your first system, and your second system goes right on top. They are the exact same equation. What you have to be able to discuss is the slope and y-intercepts. Like you would say same or different. So if they are the same equation, what would the slope of both of these lines be? The same. The slopes are identical. Slopes are the same. So let's write slopes. You can either write the same, equal, identical. So slopes are the same. The y-intercepts, because they are identical equations, the y-intercepts are the same. The next scenario was lines that are parallel. So draw two parallel lines on here. System 1, System 2. Wale, two parallel lines. How many solutions will these have? 0. So write 0 or no solutions. Again, you need to be able to tell me about the slopes, and actually it says here, but I'm just going to cross it out because you need to be able to understand this. You need to know about the slopes of parallel lines and the y-intercepts. So if they are parallel, slopes are what? Yes, slopes are the same. And you would always just do a little sketch, right? I recommend when you do these questions, have a sketch of these three different scenarios, and then you could answer all of the questions. So the slopes are the same if they're parallel, and then you just look at the picture, y-intercepts are different. So y-intercepts are different. Last scenario, if we've taken care of infinite and parallel, last scenario was lesson 1, which is one solution. One solution, you could draw a sketch of that. This is the example of one solution. What are the slopes? Same or different? They are different. One is always going to be positive, one's always going to be negative, but the slopes are different. And then we actually don't say anything about the y-intercepts. And the reason why we don't say anything about the y-intercepts is it actually doesn't matter. The slopes must be different. If the slopes are different, you're going to have one solution. The reason why we don't say anything about the y-intercepts, in this example, they would have different y-intercepts. There is actually an example where you could have one solution and the same y-intercept and what that would look like. And you don't need to know this, right? You just need to know that one solution is different slopes. Here's the example. Yeah, it would cross right. They would have the exact same intercept here, right? So you don't need to know that. This just has different slopes. There is one solution. Last example. Without graphing. So you're not going to graph these. You don't need to graph these, right? Analyze each system to determine whether the system has one solution, no solutions, or infinitely many. So we're determining, are the equations identical? Because if they're identical, they've got infinite. If they got the same slope, they're parallel, no solutions. Or if they have different slopes, one solution. This one's nice. System 2, it's already done for us. But could somebody actually answer, what would the y-intercept of system 2 be? I know that the slope is negative 3 over 5. What's the y-intercept if they don't list it? 0. So I'm just going to put plus 0. It doesn't matter, but plus 0. Okay, system number 1. Box it in. Sorry, box in the y. Aaron, do you want that y to stay or to go? It stays. I'm going to get rid of this 3x by subtracting 3x from both sides. And then I'm going to write 5y is equal to. I'm going to order this mx plus b. So I want my mx first and I want my b last. So I'm going to write down negative 3x and the 15 is positive. I then need to isolate y, Kyle, by doing what? Not minusing, dividing by 5. It is 5 times y. The opposite of multiply is divide. From here, I have now isolated my system, and it is y is equal to negative 3 over 5x plus 15 divided by 5 is 3. First, what I always ask myself is, are these identical equations? Because then that's infinite and that's easy, right? They're not identical because this one has a 0, this guy has a 3. Then after that, I say, okay, I'm going to look at the slopes. This has a slope of negative 3/5, and this has a slope of negative 3/5. Same slope is going to be this case. This is the example of the same slope, and they have different intercepts. Because if they were identical intercepts, they would be infinite. How many solutions would I have in this scenario? No solutions. There are no solutions. B. Let's figure out B. Second equation or second system, it's done for us. Y is equal to 1 over 4x plus 2. We just have to worry about the first system. Negative 4y. Jackson, stay or go? Negative 4y. What, sorry? Go. Yeah, make that positive. X plus 8 is equal to 4y. Justin, what now? That's right. Divide this by 4 and divide each term on this side by 4. Please put in your invisible 1 because some students forget that. And then I'm just going to write it y is equal to, and I want it in the form of mx plus b, so it was 1 over 4x plus 2. Rise of 1, run of 4. So 1 over 4x plus 2, 1 over 4x plus 2. What do you notice about these two equations? They're the exact same. What that would look like is this, and if it's the same, it is identical. And then, Shaywa, how many solutions would I have? Infinite. If they're the exact same, I always find that that one's the easiest, right? You don't even have to think about it. Exact same, infinite. See, we've got to manipulate each one, but we could actually do system 1 in one step. I could isolate y in one step. McLeod, what's the step to get this by itself? Get rid of that 7x, yes. Minus 7x, minus 7x. Y is now isolated, and again, I'm going to write it in the form of mx plus b, so I'm going to write that negative 7x first. This is a positive number because there's no negative in front of it, so that is my equation. System number 2, bit more work. Aiden, do you want that negative 6y to stay or to go? To go. Let's make it positive. So we've got x is equal to 5 plus 6y. From here, Xavier, I got to get that 6y by itself. What do you want me to do? Sorry? Before we divide by 6, you have to get, division is always your last step for this. How do you get rid of that 5? Subtract. We've got x minus 5 is equal now to 6y. Now I could get the y by itself by dividing this by 6 and each of these terms by 6. I'm going to put my invisible coefficient of 1 in front of that x. And then I'm going to rewrite this so that my y comes first. Y is equal to 1 over 6x minus 5 over 6. These two, I look at them and I say, are these identical? Nope. So they're not infinite. Then I say, are the slopes the same? Nope. So they're not parallel. What's the only other case that it could be? One solution. These two are going to have one solution. This one's a negative slope, so it would look like this. This is a positive slope, it would look like this, and it would have one solution. We're going to circle the homework, and then I'm going to do 2 questions with you, one of which will be on your quiz, one on the exam. So, yes, Ainsley. Okay, so please, here's what I want you to circle. 1 to 4, 8, and actually before you flip the page to 8, number 1, it wants you to talk about all 3 scenarios. Could you just do the quick sketch? Like, so for, I want you to do number 1, let's say, and just draw 2 lines that are going to be parallel. Then it wants you to talk about the slopes and y-intercepts. And then number 2, the second scenario was this, one on top of the other. Talk about the slope and the y-intercept. And then the third scenario that it wants you to talk about was system 1 and system 2. And again, they want you to talk about slopes basically for this one. Okay, so 1 to 4, number 8, 10 and 11, I would say would be the standard of excellence questions. So we will solve those 2. And then I'll give you the rest of the time just to get the other homework questions done. Okay, let's look at number 10. It gives me one equation and a second equation. It's given me 2 different equations, which means it's given me 2 different systems. So I'm going to put, I always do my first system in blue, and I do my second system in red. The other thing I'm just going to box and that it's telling me is that there are going to be infinite number of solutions. So I know if there's infinite solutions, the equations are what? Yes, the same or identical, whatever you want. Okay, let's get system number 1, isolate y. It's got a k with it, which is what we're going to be figuring out what k is. But I'm going to box this in. I want to isolate y like I normally would. I say y is positive, so I'm going to get rid of this 10x. Then I have ky is equal to, again, do slope first and then y-intercept, so negative 10x minus 8. My y is still not isolated. Maria, how do I, or what do I have to do to get that y isolated? Sorry? Get rid of that k, divide by k. So divide this side by k, this side by k, and this side by k. Now I've got my first system, and is y is equal to negative 10x over k minus 8 over k. So it looks like a mess. Don't worry. Let's figure out what system number 2 is. So system number 2, try to isolate the y. So let's add 6y to both sides. And you would have negative 15x is equal to 12 plus 6y. Now my y is positive, but I've got to get rid of the 12 and I've got to get rid of the 6. So first, I'm going to get rid of the 12. And I would have negative 15x minus 12 is equal to 6y. Last, you do your division. Divide by 6, divide by 6, divide by 6. Y is equal to, what is negative 15 over 6 reduced? Yes, that reduces to negative 5 over 2, right? That reduces to negative 5 over 2. So negative 5 over 2x minus, and then 12 divided by 6 is 2. Okay, so how would you solve this? You know that if it's infinite number of solutions, these equations have to be identical. What that means is if I know that this has a y-intercept of negative 2, right? What does this y-intercept need to be? Negative 2. So if they are identical, I'm going to let this y-intercept equal this y-intercept. They have to be identical. So write down negative 8 over k is equal to negative 2. You want to isolate k. It is being divided by k, so multiply both sides by k. Okay, sorry about that. You want to get k by itself. If something is being divided by k, you could multiply both sides by k, and then k over k would cancel, and you would have negative 8 is equal to negative 2k. Now we got to isolate k by dividing this side by negative 2 and this side by negative 2. And now I've got k isolated, and k is equal to 4. Let's check if this makes sense. If I put a 4 here, because we just solved that k is equal to 4. If I put a 4 here and here, what is my y-intercept for system 1? What's negative 8 divided by 4? Negative 2. It's identical. What is negative 10 divided by 4? What does that reduce to? Negative 5 over 2. So these are going to be identical equations. They are infinite. We're going to do something very similar for this one, except this one's going to have no solutions. So after we'll figure out what no solutions means. Okay, we've got two systems. System 1, System 2. This time we're figuring out what A is. You need to get System 1 by itself. So get rid of that AX by subtracting by AX. That would give us 5y is equal to negative AX plus 10. From here, I'm going to divide by 5, divide by 5, divide by 5. This equation is y is equal to negative AX over 5 plus 2. So that's my first equation. My second equation, or my second system, I'm going to keep the 2y and I'm going to get rid of the 6x. 2y is equal to negative 6x plus 7. Isolate y by getting rid of this 2. The equation of my second system is y is equal to negative 3x plus 7 over 2. So there's my two systems. It says that there are no solutions. What type of lines would be no solutions? Parallel. What is it about parallel lines? Same slope. It's the slope that matters. So the slope of this guy is negative a over 5. The slope of this one is negative 3. If this one's negative 3, what does this have to be? Negative 3. So let you make them equal to one another. We do the exact same thing. So make them equal to one another. Negative a over 5 has to be negative 3. You're going to solve for a. So you've got to get rid of that divide by 5. So you're going to multiply both sides by 5. And you're going to get negative a is equal to negative 15. What is that negative, really? That is a negative 1. It's negative 1 times a. So if you have a negative a, you divide both sides by negative 1 to get rid of that negative. Now your a is positive, and it is equal to 15. You always want to double check, though, right? So if I go over here, and if I erase that a, and I put a 15 there, I will have negative 15 over 5, which is what? Negative 3. This would be negative 3, and that would be negative 3. They have identical slopes, but different y-intercepts, so they are parallel.